proof of formula for derivative of dot product of vector functions. All right, and basically if you have a dot product of two vector functions, the derivative is equal to, well, just using basic product rule, but with dot product there. You have a normal product rule for that. So what we'll do now is, so let's expand the dot product and write as a summation, but first I'm going to let u of t equals 2, and what I'll do right here, I'm going to write this as f1. So the components are f1 of t, and then f2 of t, and then f3 of t, like that, for the z component. And now let v of t is equal to, now that's f, so let's use g now. So g1 of t, g2 of t, and then g3 of t, like that. All right, so then the dot product of this, so then recall the dot product. Well, this is just going to be, I'll write that and then write then u, like that, u of t dot v of t. This just equals 2, and if you recall, basically dot product, you just multiply this by this, so each component and add them up. So you multiply by their corresponding components and add them up. So we're going to have a f1 of t times it by g1 of t plus f2 of t, g2 of t, like that. And then we'll have a plus f3 of t, then g3 of t, like that. This is like that, t, like that. And now what I'll do now is my calculus book solves it. It writes it as a summation. So this equals to the summation from I equals to 1 up to 3, and then we'll have fi of t, gi of t, like that. All right, so basically what we've done is taken the dot product and then write it as a summation. So now the ordinary product rule gives, and we'll just write this out. Yeah, and that's because we're going to be taking the derivative of these two. So these are two normal functions, but that's using a summation. So instead of just doing it on one term, but you're doing it multiple times. So it's still the basic ordinary product rule, but for just multiple terms added up. So let's take the derivative now of this. Again, the product rule. This is equals to the dot product of the beginning one. So u vector dot product with v vector. So we know what these equal to. So this equals to, in terms of the summation, which is a normal product rule, not a dot product. So this is going to be the d over dt is equal to the derivative of the summation from I equals to 1 up to 3 of f of I t, and then g of I of t, like that. And now this equals to, well, this is the same thing as just writing just the summation. Let's write it here. This equals to put it inside the summation, because it doesn't matter, because you're going to just do it separately. So it's 3. It's just using basic summation rules. And now this equals to d over dt of, and now the inside product there, f of I t, and then g of I, yeah, g sub I of t, like that. And now the derivative of these, this one for each single one, we just apply the product rule. So this is going to be f sub 1 prime of t times by g of t, g1 of t, and then plus f1 of t times g prime of t, and do that for each one. So in other words, we're going to get a summation of the product rule of derivatives. So this is I equals to 1. This is going to equal 2 now. We just take the derivative using product rule, fi prime t, gi t, like that, and then plus, now the reverse way. The reverse way is basically f prime of t, and then times by g prime of t. So derivative of the f times normal g times, and then plus the normal f times derivative of g. So that's what we have. And now we have a addition. We have an addition in the summation. So we just separate these into two summations. So this equals 2. This is I equals to 1. And now we have a, put this in a, yeah, we just write it like this. Fi prime of t g prime of t plus summation, write this a bit better, 3I equals 1 f1 of t, and then g prime like that, of t like that. So that's what we have there. And well, what does this equal? This just equals to the dot product this is the dot product of the terms that have f. In other words, that's dot product with u prime. Because remember here, so remember here, this part here, the dot product, this dot product equals to this. So, but now if we're having the prime there, this means we have to do the prime. Yeah. So then, in other words, these are equal to so this equals to it's just a dot product with the u vector prime, and then the other one is just v prime t normal plus. Now this one is going to be u vector like that of t. Yeah, we're just going backwards now, and now this is just going to be and this is a dot product. Yeah, for the dot product there. So dot product. This is going to be dot product. Yeah, here I just fixed that up a bit, made it a bit more separated. See the dot product. And now the next one is u prime of t dot v prime t. Yeah, so these primes, these are all just the the v primes there. And that is just the dot product there. And this is basically, we just solved theorem 4. All right, yeah, so that's theorem 4, and we just box this in. Yeah, so that's fascinating stuff there. And I'll just do a check mark there. And again, we have the dot product here becomes the summation, and now we just have a prime there. So now we go reverse, but we have a prime in each one, and the prime just becomes over there. So there's the dot product for theorem 4 like that. So u dot v becomes like a product rule. So derivative times the normal, and then dot product the other one, and then normal dot product the derivative. So fascinating stuff.